Oh,
Excellent. So, well, welcome back, everyone. I hope you're suitably refreshed and have done all you need to in your rather short break of only 15 minutes. But we're getting we'll have a 50-minute lunch break as well. So, and that's not too far away. So, without further ado, I'm delighted to introduce our next speakers, which is, I believe, a joint presentation by Ian Bailey and John Kendall from Telicent, and they're going to be talking about the simplification in integration architecture for dimensionalism supports. So I think I can see a presentation up here. Claire, does that look right, what we've got?
Are you seeing the full screen, or are you seeing the...
I think we're seeing the full screen, aren't we?
Yeah, we're seeing the full screen. Yeah, that's good.
Excellent, that's wonderful. So people like me who don't see that well, it's always good to see a full screen presentation. So that's brilliant. So same as before then, Ian and John, you'll be talking for about 30 minutes, and then we'll have 10 minutes of questions up until 12:15. So thank you very much, and it's over to you.
Thanks. Hi, it's just me. John's not been involved in this set of slides because it's not covering the area he covered. I will name him when it comes to his bit, though. So
all right. Well, thank you, Ian. Thank you for presenting.
Right, so it's a bit of a mouthful of a title, that the simplification and integration architecture that 4D supports. So what I'm going to do is go through a bit of history of all these 4D ontologies, where they've been done and all that kind of stuff. And then I'm going to skip through that fairly lightly. I've got a bunch of lessons learned at the end of the slides, which you'll be able to pick up and look at later on. But I'm really then going to go into a little bit more about the data architecture side of it rather than the kind of enterprise architecture, though we'll cover that. Anyway, you'll hopefully it'll all hang together and you'll get the idea. And there we go. Right, so that's a bit on me. I won't dwell on that. You can pick that up in the slides later on. So this is the 7 circles of information management. And we're at the integration architecture level of the 7 circles. So this stuff goes back a long, long way, and right back into the 90s. They probably weren't initially 4D then, but they were close enough that you kind of get the idea. So as I say, I'll go through a very quick run through these, but the earliest one I'm aware of was the single table model work that was done in Shell in the early 90s. It might even have been back in the 80s, Matthew would know. But these guys were doing stuff. They'd realized there were a number of limitations of relational databases. You know, you were once you'd sort of set your data model, you were kind of stuck with it. They were quite hard to change in use. And they wanted to introduce more flexibility. So they started to work at ways of using databases in non-traditional ways that allowed you to store any data model that you could change over time. And that ability to change your data structures and adapt with changing circumstances, threats, new business ideas, all that kind of stuff, is a theme that runs through all these. So whilst this isn't 4D, that idea of flexibility in use and extensibility in use started with these guys. And I name check a few of the people in there because I don't think they get enough mention, because they did a lot of that early work on this. They spun it off into a company called Kaleido, which I think is now part of a much bigger company, but you could actually buy off-the-shelf tech to implement this stuff way back when. So, and then we have Pippin project. I was kind of heavily involved in this, and I think a few people on this call were heavily involved in this. It was an EU funded program, and it was looking at taking process plant standards, ISO 103.03.221. They're always a bit of an acronym mouthful, these things. And 15926, which I was going to mention. At the time, 15926 was still in draft when we did this work. But what we were about was trying to find ways to implement these 4D data models, ontologies, call them what you want, in relational databases, because at that time, and it's probably still true to this day, that most big corporations, government departments, the answer's Oracle, what's the question? So you had to find ways to try and implement them in the database of choice that was in their data center. We learned quite a lot on that. It is quite tricky to do. ontology work in relational databases and get them to perform at scale. We learned a few tricks for doing that. But generally, I think most people came back from it thinking maybe a different database paradigm would be ideal for this. Triple stores were just starting to emerge at that time. We tried some OO databases. I can't remember the name of them. One was called ONTOS, I think. One was called Objectivity or something like that. And they were okay, but still OO and ontologies don't really fit that well either. So a bunch of lessons learned in there, and we did figure out how to get some performance out of relational databases with these things. Then came Shearwater. Now Shearwater was really interesting. Now I've picked out Shearwater. There were a good half a dozen to a dozen big data warehouse projects that happened around this time, late 90s, early 2000s. A lot of them in Norway, a lot of them in the UK. So BP did one at Shearwater. I think there was even a US one in the Gulf of Mexico at the same time as well. And this was a much more pragmatic approach. We weren't trying to squeeze the data into a relational database. We kept our reference data library fairly minimal. And I think it was widely agreed it was quite a successful project, this one. We used a target system from a company called Quillian, which was a Cambridge startup out at St John's Science Park in Cambridge, so fairly close to you guys. Yeah, and it was really good, and a lot more was learned on that about what works and what doesn't, and we really went to town on leveraging data quality and figuring out what works and just really focusing on that. Then there was Downstream 1. This was one, I think, Matthew be able to confirm, I think it had the honor of being the world's biggest IT program. It was certainly the world's biggest SAP rollout. And it was about unifying the way SAP was used across all the Shell operating companies. Because traditionally Shell allowed a lot of flexibility in how their operating companies worked, but that made it more difficult to get consistent reporting from them all. So in this one, we used 1596. Again, Matthew's the expert on this. It was his program, so he'll be able to tell you a lot more about it. But it's probably the first time I'd encountered the Burr methodology, which is Chris Partridge's methodology, and it's probably the first time we'd really applied it in anger to oil and gas work, I would say. Then there was the Ideas program. This was another one that it was government-based rather than oil and gas. And this was across a number of nations, the defense departments of a number of nations, trying to find a unified way to share data. So it's a data standards project again. Again, a lot of implementation on there. The one thing we learned is that you can't just let people loose with an ontology. They do need a bit of practice and they do need some training. I'll put a comment on there, little knowledge is a dangerous thing, and we certainly found that to be true. So yeah, we learned quite a lot on that one as well. And finally, another project, IES. This one is current. There are a whole bunch of government departments involved in this now and various agencies and so on. And this one is about using a 4D ontology to share data between government departments, particularly in the area of law enforcement, defense, and national security. So it's about sharing historic data about things that happen and places and people and all that kind of stuff, and all the legal stuff around it, around warrants and all that kind of stuff. So that's another really interesting project. I think some of the guys from the IES standard are probably on this call and could probably pick up any questions on that. Anyway, so the reason for going through all those at a real dash, and you'll get a copy of these slides to have a look through in your own time, was to point out that amongst the guys who've been working on this, there is a lot of experience. You know, there's many years of experience trying to implement these, working out what the pragmatic approaches are and how to get the best out of it. And there are quite a few people now who understand 4D ontologies and can do work with it. Anyway, so all that behind, I'm now going to try and tease out from all those projects. This is a bit of a personal view, and I'm sure there are other people who've got other views on there, what it is about these 4D approaches that make them, you know, fitting with the title of this slide, how it makes integration architecture easier. And I think the chief reasons are actually at a data architecture level, a finer grain level. I spent a lot of my life doing enterprise architecture work, but I think the real benefits from this stuff are actually at the ground level in the data as you work with it. So I hope the government folks in here don't mind, but I have stolen some slides from the IES training pack. I've asserted the Crown copyright on this, so I hope we're okay. But for me, the thing that makes integration easier with these type of models, and this is not necessarily just a 4D thing, I think a lot of ontologies are smart enough to do this. You know, a traditional data model, you define a bunch of classes, or you define a bunch of tables or entities, or whatever you want to call them. And then you build your system around that, and you populate those tables, those classes with data, and it does what it does. And then if you want to do something else with it, well, you pretty much have to chuck it away, because it's really quite hard work when you've built an application stack on top of these things. These databases don't like to be changed in use. They're really hard to refactor in any significant way without huge knock-on effects on the rest of your architecture. And the interesting thing about these approaches is you don't get that fixed set of buckets into which you put your data. What you get are a bunch of fine-grain interoperable parts of a model that you can stick together in different ways to do things. So my analogy here is that, you know, if you want to build a model aircraft, you can go buy an Airfix model and you get a really good looking aircraft, and it might be the one you want to build. In that case, it's a, what do you call it, SR-71 Blackbird. And that's fine until you decide what you actually wanted was a Spitfire or a model car or a 747 or a house. And then you're stuffed. You really got to get the hacksaw out and start melting plastic down if you want to change that into something else. Whereas Lego, on the other hand, you can build something that doesn't quite look as amazing. It's a little bit hard to get your head around, perhaps, understanding why it is what it is. However, you can change it in use. And the other really interesting thing about it is the bits on it move. They're not all glued together. You can do more interesting stuff with it. I realize it's probably a rotten metaphor, but the idea of these ontologies is you've got lots of fundamental components. And I think Chris is probably going to go into this a bit more in his presentation later on, that you can reuse in consistent, well understood logical ways, which allows you to build models on the fly for very different purposes. So you get a lot more flexibility, you get a lot more resilience to changing circumstances in your systems, which is a real thing for me. You know, Agile's fine when you're building it, and then when it goes into operation, you've still built something you can't change. So the idea of having something that where you build in flexibility and don't store up any technical debt is quite useful to me. What's the other bit about it that's really cool? Well, you've seen a lot of 4D presentations already, but the 4D approach demystifies a lot of things that people in data models tend to treat as intangibles, you know, like activities are intangibles, for example, and that kind of thing. The 4D approach allows you to demystify these, take the nonsense out of it, and actually model what you're dealing with. But it also allows you to deal with how things change over time. And that's really useful, particularly, it's no accident that government and oil and gas are two sectors that are really interested in this approach, because they have huge compliance requirements around them. Knowing what you knew and what the state of things were historically is really important. But traditionally, they never built their systems or their data models to deal with that. So 4D and this approach to space and time, and there are people presenting today who can give you all the philosophical terminology that goes with this that I probably don't know. But I personally, as an engineer, find this a really good way to work with data that changes and moves over time. So in that example there, you know, you've seen these space-time diagrams before. They crush up the spatial dimension to one axis. So if it moves around on the y-axis, it's moving in space, and then temporal axis stays as it is. So you can then divide things into states. So now we've got 3 states of Fred. One when he was born and he weighed 3.5 kilos, another one when he was a child and he weighed 25, and then another one when he was an adult and he weighed 92 kilos. That becomes clear. There's a consistent way to deal with that. It's the same thing reused over and over and over again. I find that particularly good for dealing with data in an additive way, so you're not having to constantly break and remake your data. You can keep adding to it. It's been really good. There's some good books on this. There's Matthew's book and Chris's book, obviously. But I'd also recommend How Things Persist by Catherine Hawley. It all gets a bit philosophical, about 10 pages in, but the first 10 pages are quite understandable, which is about as good as it gets with logic and philosophy books, I find. So the first 10 pages are good, and it will give you a good idea of what's going on. You can probably find them online somewhere as well, I would have thought. And another thing that makes this stuff easy. Now, this is what's known as the Barrow naming pattern. Now, according to the Barrow naming pattern, there are very similar patterns in use in other data standards. But, you know, the combination of this with the 4D, I think, is really good. So what this naming pattern allows you to do is add multiple identifiers at will, on the fly, to your object. So you've got something you're interested in, you can add an identifier to it, but when you add it, you say this identifier belongs in a naming scheme, and that naming scheme is owned by an organization, implemented in a system. You can say all kinds of things about the naming scheme, but there's ability, again, it's additive. You can just keep adding new identifiers to things when you discover that, you know, one standards body calls it this, another standard body calls it that. You can just keep adding those names. When you know a system implements a particular identifier or a name or some kind of codification, you can add that system to the naming scheme as well. From a data sharing and data integration point of view, this thing is really, really useful. Programmers, I find, don't like it because they don't really want to be chasing down a bunch of links to find an identifier. I have to tell them to suck it up and deal with it. These identifiers are a great, this way of dealing with identifiers is a great way to cope with multiple sources of data and bring in data from completely orthogonal views sometimes. In terms of the actual identity of the thing, Chris will give you a chapter and verse on how you tell if one thing's the same as another. But in terms of how you label this stuff, we find this really, really useful. So that combined with the 4D approach and combined with that kind of Lego approach I was talking about earlier, where you've got lots of little components you can stick together to do what you want to do, it just makes it absolutely great for doing data integration. Finally, one thing I would suggest that is really useful, and this sometimes doesn't always click with folks who are into reasoning and first order logic, is the ability to add new classes to your ontology as you go along. In fact, a lot of the data you produce is classes in these 4D ontologies. Again, Chris will give you a chapter and verse on that later on. But that ability to effectively extend your model, but also to be really clear about what's a class and what's a physical thing is really, really useful as well. And that's quite blurred in a lot of data models. So you're improving the quality of your data by doing this as well. You know, and it's great because you can work with the same data standard over time. It extends its life because you can make in-use extensions to it really, really easily. It extends the life of systems as well, and it makes systems more robust and resilient to new types of data coming in. So I think the things I've covered there are really what make these 4D ontologies great for integration architectures. So that boils down to basically these key points really. You increase your flexibility, you increase your consistency, and I think Matthew's already covered quite a lot of that, and Al and Chris will also cover that. Quality's improved, I guess that comes with the consistency. The diversity's improved. You have longer living systems that can deal with much more diversity of data. And the precision, you're clear about what things are and how they relate to each other. Now, you don't always need all of this. And some of it, as you probably saw in some of those early slides, some of this stuff is quite hard work and some people struggle to grasp it. You know, there's a lot of effort goes into doing this right, and it's not always worth it. I know we're supposed to be selling 4D here, but let's be realistic. It's not something you would apply to ephemeral data that's in 1 minute and gone the next. It isn't worth the effort to clean that up and go through all this kind of complexity. But stuff you want to keep that's high value data, and a lot of data falls into that category, it's absolutely great for it. Right. So I just wanted to get that out of the way, because this is a whole bunch of lessons learned from doing this stuff for donkey's years, and there's people on this call who've been doing it even longer than me, and I think it's really useful to know these things. But I'm now going to go a real step up to the kind of enterprise architecture, because I think this is kind of what Matthew wanted me to cover in these slides anyway, which is the enterprise architecture of how you fit it all together. So this is from the architecture document for the National Digital Twin. I think that's just going through publication, though it's not quite out yet, but it's been out for review. We've had a bunch of comments on it back. And as was mentioned earlier, what we're trying to achieve here is a way to have a number of digital twins that share all or some of their data in a secure way between them, and an ability for one digital twin to be able to find data that it needs from another one and retrieve it back, whilst maintaining some central control. Now, I emphasize the some, because if you push all your control to the center, it becomes very hard for people to do what they want to do at the edges. So it's a case of picking your battles and knowing what you want to standardize centrally and what you want to manage locally, and having ontologies that are extensible in use allows that to work really well. And this is the kind of, so this is the logical approach. We're calling them nodes because they don't necessarily correspond to an individual digital twin. You know, it could be a project that has 4 twins in it. It could be one big digital twin for a city or a large building or something like that. This is very much a logical architecture. So it's just about what gets centralized and what gets moved out, and it's a federated approach. So I said I was going to name check John Kendall. So Dr. John Kendall has been helping us with this. He wrote the report and developed the enterprise architecture view of this. So coming down to a more physical approach, this is the kind of approach we used in the 90s and into the 2000s to do that. And it's a fairly common one. It was called data warehousing. Probably wouldn't be that familiar to people who've worked in data warehousing in retail, for example. We kind of hijacked the term back then. But in some ways it's similar. You've got lots and lots of data sources, and they all end up being pushed into one central standardized store. And that's usually used for handover. So, you know, when say AMEC or someone like that builds a refinery or a rig for an oil and gas company or a chemical company, there's a lot of data to hand over to the operating company. And that's what this was really all about, getting all that data from all those sources into one place, into one implementation that could then be used by the operator through life. So it's that switch over from design to in use. It's great, but it's very rigid and probably doesn't work quite so well for the digital twin approach. So kind of where we're pushing towards, and we're keeping it logical, but we do like the idea of event sourcing models for the digital twin, because that's a kind of federated synchronization approach. So you've got a bunch of source systems. Every time something changes in those systems, that event, the event is detected, converted to the standard format, pushed onto the event log, which is a bit like an enterprise service bus, I guess, but more sequential in nature. And then that can be picked up by other systems. In particular, it can be picked up by the digital twins. The digital twins are implemented using the standard data model, so no mapping is required on pulling them back in. And then those digital twins present their own APIs to users and user interfaces and all that kind of good stuff. But the beauty of this slightly more decoupled approach, where you don't have one central store, is that it lends itself a little bit better to the federation. So you can have project-based digital twins, and you can have your core event log that's doing some synchronization of the core standard stuff between them. But in the most time, they're just talking to themselves, and they only go back to the core or talk to each other when they need to. So we kind of like this approach. I think on the previous slide, there's a link. Yeah, there's a link to Martin Fowler blog on event sourcing, which is a really good explanation of how it works and the benefits. And and difficulties with it and the gotchas. You know, it's not, no enterprise architecture is ever perfect, but we kind of like the way this fits with the digital twin approach. So hopefully I've kept within time. So as I say, there is decades of experience out there and a lot of lessons learned. I think key ones are, it's all about getting people to understand this first. It has to click, and that needs a bit of training and a lot of experience. Chris always talks about working out an apprenticeship in these kind of ontologies, and it's true. You really do need to kind of rewire your brain a bit to work with these. Getting the best out of 4D is a case of picking your battles. You don't really want to be applying it to everything. It's really best applied to that kind of data that you really care about, that's high value, because it requires quite a lot of effort to put into it. Managing reference data, a light touch with that, you can really bog yourself down in reference data. Our Norwegian colleagues found that early on, that it becomes quite hard work to manage very large data sets that are structured. And then from the enterprise architect point of view, we kind of like event sourcing. It seems to fit really well with the W3C RDF stack, you know, the linked data semantic web stack. So we think that's a good way to go for at least for prototypes, and we'll kick the tires and see how it goes. And then looking forward, the guys are working on ontology that we can test with, but we need to build some demonstrators now and work out where these architectures work. So we're going to pick one of the existing 4D standards. Could be IES, as that's a recent one, could be ideas, could be ISO 15926 or the Shell high quality data model. Any of those will do for kicking the tires and testing this, because they're all very similar. They're all based on the same fundamental points. There's more stuff at the back end of these slides about lessons learned and going into detail, but I'm not going to dig into that. So I'll hand over to questions now.
Thank you so much, Ian. That was a really, really interesting presentation. I can see there are some questions coming in. Ian, I don't know if you want to open up the Q&A tab yourself, but I would say the first one, starting from when you kicked off, is Keith at 11:56, who asks, how fine is fine-grained precision? Or rather, how do you know what level of granularity you need?
Well, if you don't know what level of granularity you need, you probably need to go back and address your business requirements a little bit. As in Matthew's presentation start, he talked about, do you go down to individual atoms or not? And the question is, what do you need to do? So it depends on your project and how deep you want to dig. There's no point going right down to the subatomic level if you don't care about that. And there's no point going down to the component level of a product or a building if all you care about is the whole building. So you can choose your poison really with this stuff. You can dig in if you want to. The other thing I'd say earlier, as I mentioned earlier on, these models tend to be additive. So you don't paint yourself into a corner by choosing to not go fine grained. If you choose a real coarse granularity to start with, you can always dig in later without breaking what you've done. Which I really like. It's one of the really nice things about these approaches.
Thank you. Ian, can you see the next question, which is from Peter Parslow? Or do you want me to read it out?
No, I can see that. Yeah, you can add classes to data models. You just can't add them to databases. That's the difficulty. Relational databases don't lend themselves well to being restructured in use. So that's why they started to do all that work on the single table model and Kaleido and all those data warehouses that came out at the same time. It's also what drove Martin Fowler. If you're familiar with Martin Fowler's work on adaptive object models and, oh God, what's it called now? I haven't got the reusable object structures. That's from early 2000s, I think. There's been a lot of thought gone into how do you increase the longevity of your data intensive applications by building your data models in such a way that they're extensible. So I agree, you can keep adding classes to them. Whether you can keep adding those to your implementations are a whole bunch, whole different question.
Keith May was asking at midday about does getting granularity precision need a feedback loop to test against the domain specialist's expectations?
Yeah, I reckon. Yeah, I think that's a really good call, Keith. Yeah.
Alex is asking about how do you do discovery of information in the NDT nodes? Is information centrally indexed or are queries federated to the nodes?
That's a really good question. The access control model is going to dictate a lot of that. So I think the federated discovery is one of those big questions. So you should be able to push a search out to all the nodes you're able to see. Some of them will be private, don't forget. Some of these things will be private infrastructure we don't want anyone else to look at. And then individually within there, as mentioned in Al's presentation, we think we're going to push for ABAC, attribute-based access control. And provided your credentials meet the right attributes, your search should return the data you're allowed to see from each of those nodes. Now, the question, do you want to replicate that data into your own node? Again, with an event sourcing architecture, that's an easy choice to make. You can choose not, once you found it, if you want to keep a copy locally, you can do that without breaking anything. So we kind of like that event sourced approach.
Alex then says, how much of this is implemented?
For National Digital Twin, nothing. I mean, I'll fess up at this point. I work for a software company and we are building a data sharing platform called Memphis, which works on these principles. I guess we've done a lot of learning from this program though about how that would be shaped and how it would work. So we've implemented some of this. So Paul Cripps is on this call from DSTL, and we've been doing some work for Paul on an international project where we've implemented a very similar event sourcing architecture for sharing data between it's maritime information on shipping between various countries and their border controls and that kind of stuff.
So Ian, a question from down here, has blockchain technology featured in the federation/decentralization of NDTP?
Yeah, it keeps coming up, and I'm really interested. I don't know if you're Dan, I don't know if you've looked at DApps or DApps, or however it's pronounced today. I don't think the tech's quite there yet with the apps, this distributed apps idea, but Moore's law and all that will be there soon enough, and I think that's the way a lot of this will go. So DApps is worth a look. Performance isn't great with blockchain stuff. The crypto kind of gets in the way. I know there are mitigations for that. So I suspect we will probably use it for things like contractual stuff, but for the actual transactional data shifting around between systems, I can't see it being applicable yet. But as I say, Moore's law, in a couple of years' time, that might be something we'd be looking at.
So Ian, there's quite a long, a detailed question at 12:02 from Paul Cripps. Can you see that?
I'll just ignore Paul.
But there's a.
I'm answering that one.
Okay.
Consistency has been mentioned a few times now. Blah, blah, blah. No, I agree. Yeah, you definitely need governance, Paul. There's no doubt about that. You can't just willy-nilly allow anybody to create whatever they want. There have to be levels of governance, but that's the key, levels of it. So your core data model is very tightly governed, your upper ontology, and then maybe your domain ontologies are governed but slightly less governed. Then you've got project-based stuff, which is a different level of governance. And again, I'm a big fan of W3C's ontology stack. I think that modeling approach gives you a really good way to do layered governance across your ontology. So yeah, it's about, again, picking your poison, picking your battle. You want really tight governance at the top around all the ONTIC categories and all the core logic stuff, and that loosens as you go down the tree. That's my view anyway.
Thanks, Ian. One from Nigel, which follows up from that. He says, following Paul Cripps' question, could a class definition be advertised/published as part of a discovery process?
That's a really good question. That came up this week in another project I'm working on. Yeah, absolutely. I think it's vital, because if you don't do that, you find you get lots of little cottage industries developing the same classes with different names. So it probably is really useful to be able to share that out and let the community know, hey, this team over here has seen a requirement for a new class. And then if you start to see that getting used elsewhere, that's probably a good reason to push that up the standards governance layers and control it a bit more and make it more reusable. Yeah.
Okay, there's 3 little comments from Dan here, comments/questions.
Oh yeah, yeah. Well, it sounds like Dan knows more about DApps than I do, so I'm not going to embarrass myself there.
Something from Drago here. Read Dan's question. Scalable IOTA and Avalanche offers better scalability and bandwidth. I think that's more of a comment. And then we have a question from Neil Thompson. I was about to ask about distributed computing. What about more traditional peer-to-peer systems, Napster for infra data?
In a way, I quite like these. I keep saying I like these events. I mean, I'm building an event sourcing system right now, so I would say I like it. But there are some similarities there that you can replicate, and you can have local contracts between peers about what's shared and what isn't. So if you apply, and that's probably initially where some of the blockchain ideas and electronic contracts would come in. You can agree between parties what's shared versus what's discoverable and who has right access to what within a peer-to-peer network, and you can grow. It's almost fractal rather than peer-to-peer, if you see what I mean. It's quite a nice way of working, I think. It needs a lot of governance, but everything does. Your data quality will just fall apart if you don't have governance across the whole thing.
Excellent. Perhaps we'll just finish with this last little question from Andrew before we move on to David. Andrew says, we use a hierarchy to help us discover parties. So that's more of a statement really, but I don't know if you want to comment on that, Ian.
I think that's, yeah, same sort of idea. I think, yeah, you would be, I don't know if it's a hierarchy or a graph. I'm always a bit reluctant to opt for hierarchies because they always feel a bit constraining. So it feels more like a network or a graph. But yeah, that kind of idea. Yeah.
Lovely. Look, Ian, thank you so much. That was so interesting, and thank you for getting through all those questions. You obviously stimulated a lot of interest for people to ask that many. So, well.